right, so 4.6, arithmetic sequences. Students will be able to identify the next three terms in a sequence and write an arithmetic sequence as a function, okay? So they're going to give you pretty much a sequence, and then we're going to use that sequence, the patterns, in order to write a function for it. All right, so what exactly is a sequence? A sequence is a list of numbers. A sequence is a list of numbers. Okay, so a sequence is a list of numbers. Okay, and a term is what you call each number. So a term is what you call each number. It's each number in a sequence. So a term is each number in the sequence. Okay. All right, an example of a sequence is right there, 5, 10, 15, 20, 25, and so forth. This first number here, this is your first term. That's your first term. The 10 would be your second term. The 15, that would be your third term. And then you got your fourth term, fifth term, and so forth, all the rest of them. And then this right here, you see this A sub n? This stands for your nth term. Your nth term. Or your nth position, because we don't know the exact number. It just represents the place value. But that's known as the nth term. Okay? It could be the 20th, the 30th, the 50th. It could be the second. It just represents a term somewhere in there that we don't know the exact value of it, and we don't know the exact position of it just yet. All right, an arithmetic sequence. An arithmetic sequence is a list of numbers with a common difference. Arithmetic sequence. So let's write this down. A sequence that has a common difference, or a list of numbers with a common difference. Difference means subtract, so what that means is if you were to take each number, they add the same number each time to get to the next number. So an arithmetic sequence is a list of numbers with a common difference. Okay? All right, so let me show you an example. I guess I don't have an example. All right, so let me write down an example of an arithmetic sequence. 5, 10, 15, 20, and on. Okay? How I know this is arithmetic, to get from 5 to 10, you would have to add 5. And then to get from 10 to 15, you would have to add 5. To get from 15 to 20, you would have to add 5. Okay? This here is your common difference. The plus 5, notice they're all the same. So that's why it's common, because they're all the same. And difference, it's the difference between the two numbers. If I were to subtract 10 minus 5, I would get 5. 15 minus 10 is 5. 20 minus 15 is 5. So they have a common difference. You're adding the same number each time, or subtracting the same number each time. All right, let's look at an example. It says write the next three terms of the arithmetic sequence. So what you want to do is go through and figure out what pattern they're using. What's the common difference? It already told you it's arithmetic, so we already know that it has a common difference. We just need to figure out what it is. So you need to figure out, they go from -7 to -14. Now, you can either be really, really good at figuring out the difference, if you can do it in your head. Sometimes it gets difficult. So let me show you how to figure out the difference when it's difficult. Okay, so to figure out your common difference, you would take the second number and subtract the first number. So like you would do negative 14 minus negative 7. Okay, so type that in your calculator for me and tell me what you get.
Negative 7.
Negative 7. So that means the common difference is negative 7. All right, now do it again with the next one. You would do negative 21 minus negative 14.
Negative 7.
Okay, and then do the last one. Okay, and this one, don't call this answer out just yet because I want to make sure everybody understands how to do it. Negative 28 minus negative 21. Austin, what did you get when you typed that in?
Negative 7.
Negative 7. So notice each time they're subtracting 7, or you could say they're adding negative 7. All right, so what you need to do is figure out what would we do to get to the next one. All right, so Hayden, what do you think I'm going to do to this negative 28 to get the next term? Okay, so what have they done every other time? They've added negative 7. So what do you, to keep that same pattern, what do you think I'm going to do? Add negative 7. So do that for me. Do negative 28 plus negative 7, or you can just do negative 28 minus 7. And Morgan, what do you get when you do that? Negative 35. So that's the next number is negative 35, but it wants the next 3 terms. Okay. Well, I have negative 35. Cody, how am I going to figure out the next number?
Subtract 7.
Yeah, subtract 7. And Cody, what do you get when you subtract 7?
42.
Positive.
Negative 40.
Negative 42. Awesome. All right. Brandon, what would I do to get the third term?
Subtract by 7.
And what do you get when you subtract by 7?
Negative 49.
Perfect. So my next 3 terms are negative 35, negative 42, negative 49. All right, what questions do you have for me? Okay. All right, let's try the next one. This is one that was like an extra example, but I wanted to do it because I wanted us to do a difficult one together. It says write the next 3 terms of the arithmetic sequence. And it's not really difficult, it's just people make it difficult because there's mixed numbers involved. So first thing you need to do is figure out what the common difference is. So remember, you're going to type in your calculator the second number minus the first number. So you would do 3 3/4. And lucky for us, these small calculators have the mixed number button. Minus 4. So do 3 3/4 minus 4. And not call out the answer just yet, because I'm going to give everybody plenty of time to figure out the common difference. Cheney, what did you get?
Minus 1/4.
Negative 1/4. So they, you can either say they either subtracted 1/4 or they added negative 1/4. Now, do I really need to go here and do that for all 3 of these? No, they've already told me that it's arithmetic, so I already know that they did the same thing on all of them, so I already know that they subtracted 1/4 on these. I just need to figure out the next 3 terms. Okay, so I need to do 3 1/4 minus 1/4. Okay. Rebecca, what do you get when you do that?
Hold on, I'm looking for the next number.
That's fine. Three, perfect. So that's the next term is 3. Now I need to do minus 1/4.
Wait, so like to get to the next number, you're taking 3 3/4, and then you did minus.
Yes, you're doing 3 1/4, and you're subtracting 1/4. And then they got 3. So now to get the next number, you take 3 minus 1/4. And what did you get? What did you get? Okay, hit second. And then hit the, it says times 10 to the nth button. It's blue, it's the third one above the number 8. Right there. And then press enter. You know, it should change it to a mixed number. There you go.
So then it's 2 3/4.
Perfect. So 2 3/4. Yeah, if you get it like I think, what did you get? 11 over 4? If you get 11 over 4, you can hit second, and it's the third button above 8. It says times 10 to the nth, and then press enter, and it will give it to you in a mixed number. Okay. All right, so now do 2 3/4 minus 1/4. And Hunter, what do you get when you do that?
I got 5 over 2.
What is that in a mixed number?
2
2 1/2, perfect. And there's your next 3 numbers. All right, before we move on to the next category, what questions do you have for me? It says graph the arithmetic sequence. Okay? All right, so in order to graph an arithmetic sequence, first you're going to make a table. Now, if I had enough room here, I would just make a table right here. Okay, but I don't. So first thing you do is make a table. Your x value or your n value is the position, or like which term number. So that's the x that goes here. So instead of this being your x-axis, this is known as your n-axis. Okay? And then your y category is the actual term. That's your a subscript n. Remember, that means nth term. So on your y-axis, you label it a subscript n. So instead of using x and y, we're using n and a subscript n. Okay? All right, so in the first position, my first term is 4. So my first one is 4, so I would do 1 4. The second number is 8, so I would do 2 8.
Do we add anything back to this?
No, only what they have written down. The third number is 12, so that would be 3 12. And the fourth number is 16, so 4 and 16. Yes, ma'am.
Is that like a comma, a little n?
Yeah, this means term, and for your term, we use this abbreviation. All right, so I notice my numbers go all the way from 4 to 16 on the term one, so on the y-axis. So I need to have, from like 0 to 20. So I'll probably count by ones on the y-axis. And my x-axis only goes from 1 to 4. So I'm probably not going to count by ones. I'm probably going to count by halves, label every other one. So like 0 starts here. Well, this first one would be a half, so the second one would be 1. And then the fourth one would be 2, 3, 4, 5, 6, 7. And I'm only going to number it to 7 because I really only need it all the way up to 4. The only reason I would go through and number it all the way would be if they were going to be asking me, what's the 10th term? And then I might graph it. Okay. All right, so on the terms, it goes all the way to 16. So like I said, I probably want to count at least or I want to, go from 0 to 20. So I'm probably going to count by ones here, but I'm only going to label every other one, so I'm not so crowded. So that's my 0. The first one would be 1. So this second one here would be 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, some of these are kind of hard to see. 12, 14, 16, 18, 20. So I didn't really count by twos. I really counted by ones, but I only labeled every other one just because I didn't want to sit there and go through and go 1, 2, 3, 4 and scrunch it up a lot. All right, once you do that, now all you need to do is plot your point. So your first point is 1, 4, so go to the right up to the 1 and then go up to 4. And then 2, 8. 3, 312 and 416. No, because they only gave us, they did not give us like 1/2, 1.5, 2.5. They only gave us 1, 2, 3, 4. Now, my question is, what do you notice? It's going up. Okay, so it's increasing. Anybody notice anything else? It's linear. Yeah, see how it goes? See how each of them increase by the same amount? This would be considered linear. So an arithmetic sequence is linear. Do you remember back in chapter 3 or chapter 1 when we had to determine if it was linear? The way to tell if it was linear was to go through here and see if they added the same amount each time. 4 to 8 was plus 4, 8 to 12 is plus 4, 12 to 16 is plus 4. This is just your common difference. So an arithmetic sequence is really a linear function, or an arithmetic sequence is linear, and you're pretty much doing the exact same thing we did previously in a previous chapter. They're just calling them something different now. Okay. I like to see how it all ties together, how everything overlaps. All right, so knowing that an arithmetic sequence is linear, that means it increases or decreases by the same amount. That means it has a constant rate of change. Okay. So it says, does the graph represent an arithmetic sequence? Explain. Well, the way to tell is to look at your terms. You got 15, 12, 9, and 6. 15, 12, 9, and 6. Now, in order for this to be arithmetic, what would have to be true about this sequence?
Common difference.
Yeah, it would have to have a common difference. What's the difference from 15 to 12?
-3.
And 12 to 9?
-3.
And 9 to 6.
-3.
So would you say that that's arithmetic?
Yeah.
Yes. And that's because they have a common difference. Because it tells us to explain. As long as you say something like it has a common difference, or it decreases by the same amount, or the y value decreases by the same amount, or a sub n. You could also look at the graph itself and see if it's linear. If it's linear, then it's arithmetic. If it's not linear, it's not arithmetic. All right, now let's move on to writing a function. What if you're given a sequence and you have to write a function? All right, it says writing arithmetic sequences as functions. It says let A1 equal 4, and it has this part here on your paper, and D equals 3. Okay, so what this means is, let's say your position 1, your first term, how you label your first term, it would be A with a subscript of 1. And A with a subscript of 1 means your first term. Okay, so how you write it using A1 and D, you would just be your first term. You wouldn't add a common difference to your first term. Like we had 5, 10, 15, 20. You don't add anything to that first term to get your first term. You're given your first term. And here, our first term is 4. That's the actual number 4. Okay. For your second term, for the second position, that would be A with a subscript of 2. That means second term. And how you get your second term is you take the first term, A subscript 1, and you add the common difference to it. So for instance here, if I was given that my sequence started at 4 and the common difference was 3, to find the next number, I would do 4 plus 3, which is 7. So my next number would be 7. Okay. The third term would be A subscript 3. Now, to get the third term, you would start with your original, but instead of just adding the difference 1 time, you would have to do it 2 times.
So basically each time it just goes up 1, doesn't it?
Yes. Okay, so to figure that one out, you would do 4 plus 2 times 3 to figure out the next term. Well, 2 times 3 is 6, and 4 plus 6 is 10. The fourth term would have an A with a subscript of 4. That's how you would tell someone you're looking at the fourth term. And to figure the fourth term out, let's say I didn't know what the two middle ones were, 7 and 10, and I needed the fourth term based only on A1 and D. Well, you would do A1 plus 3 times the difference. Okay, so that would be 4 plus 3 times 3. 3 times 3 is 9, and 9 plus 4 is 13. So just using your A1 and your D, you need to come up with a function, because what if they ask you for the 100th term? Are you going to want to sit there and go through and go 4, 7, 10, 13, 16, 19, 22? Are you going to want to sit there and do that 100 times? No, you're just going to want to type it into a formula and find it right away. What has been the same on all of these? Yeah, you're just going up one more. Now, so to get, this says A, so the nth term would be A with a subscript of n. A subscript of n. To get that, notice each time all of these started with the first term. Well, no matter which term you're looking at, you're always going to start with the first term. And you're going to add the difference to it, but I won't add it in term. Like whenever it was the fourth term, notice I added it 3 times. Whenever it was the third term, I did 2 times. Second term, I only added it once. What if it was the 100th term? How many times would I add it? 99. What if it was? What if I said 621 term, the 621st term? 620. So notice each time you're doing one number before it. Okay. So what you would put there instead of doing the nth term, it's n minus 1 times the difference. So n minus 1 means you multiply it by the number before. So if you're looking at the 1000th term, you're going to add the difference 999 times. And in this particular problem, the formula would be, you just plug in for A1, which is 4, plus, and then n minus 1, and then times 3. It is when you first get it, but once you start working with it and using it, it makes a lot more sense.
So we'll always be counting by 1.
Oh, for your x value? Yes.
And like the D will always be like,
No, here our d's counting by 3s because our common difference is 3. Earlier, our common difference was -7, and there was a time where it was 1/4.
will it say what it is?
Yes. Well, it'll either say it or you have to figure it out.
So like your common difference like says the same though. Right?
Yes, your common difference stays the same throughout that problem. Okay. All right. So on the next one, here's the actual equation that you're going to be using. So you need to write this equation down. This is the formula you're going to be using. The numbers you're going to plug in for are A1 and D. A1 is your first term, and you're going to be given that. And D is your common difference. And like I said, you're going to be given those numbers, and you're just going to plug them into your formula, and then you'll solve it. Now, personally, I like to put my common difference in the front because I like to distribute from the front, and I don't like to distribute from the back.
Can I write it with the D in the front?
Yes, it's okay if you write it with a D in the front. Whenever you take like your ELC, this formula will be on there for you on a formulas page. You just have to know what it is. They don't sit there and tell you this is the formula for an arithmetic sequence. They just have a big list of formulas on a page for you to look at. All right, so now let's do an actual example. Now that you have the formula. It says, write an equation for the nth term of the arithmetic sequence 14, 11, 8, and 5, and so forth. And then find the 50th term. Now, like I said earlier, I'm not going to go through there and add the common difference 50 times, okay, or 49 times. So we are going to use this formula here, and you're going to plug in for the first term, which is A1, and you're going to plug in for D, okay? What's our first term in this problem? 14. So for A1, we'll plug in 14, and then I need to find the common difference. Well, what do you get from 14 to 11? What's that difference there? Positive or negative?
Wait, I'm super confused. We write that equation down on this?
Yes, you need to write this down on your paper, this formula. This is the formula you're going to use for every problem. Okay, and notice they subtracted 3 every time. So our common difference is negative 3. So that's what we're going to plug in for D. All right, so to find your nth term, to find A sub n, what you would do is 14 plus n minus 1 times negative 3. Are y'all okay if I put the negative 3 in the front and then write n minus 1?
Yeah.
Okay. Because for me, it's just easier for me to distribute from the front than it is from the back. All right, and now you just solved it. So now, or you just simplify it. So first you distribute negative 3. So negative 3 times n is negative 3n, and negative 3 times negative 1 is positive 3. And now you add your like terms. 14 and positive 3 is 17. So your formula would be 17 minus 3 times n. That's the first part. That's your formula. Now, if you wanted it in slope-intercept form, you would write it as negative 3n plus 17, but that's completely up to you.
That's all we have to do?
Well, that's the first part. So this is a formula you can use. You can write it as negative 3n plus 17 if you like it in slope-intercept form, or you can do 17 minus 3n. Either one's fine. So what this means is, if I wanted to find the third term, to find my third term, a sub 3, I would need to plug in 3 for n. So I would do negative 3 times 3, which is negative 9, and negative 9 plus 17 is positive 8. Is my third term positive 8? Yeah. So now you can do that with any term. They want us to find the 50th term. So for n, we need to plug in 50. So to find the 50th term, we would plug in 50 for n. So to find a subscript 50, that means the 50th term, we would do negative 3 times 50 plus 17. And type that in your calculators for me and tell me what you get.
133.
So if we went through and were to keep that pattern going, when we got to 50, the 50th term, it would be negative 133.
So glad we were told this one. I don't know if we did that one.
If you feel like you're going to get sick or anything, I just recommend getting that trash can. Don't try to make it to the bathroom because I don't want you to get sick in the hallway. Do you feel like lightheaded?
No, I just feel like, you know that feeling like you have a fever, like you lose it? That's how I feel.
Yes. All right, is everyone okay if I erase this? All right, let's try another one. Write an equation for the nth term of the arithmetic sequence 4, 5, 6, 7, then find the 25th term. Notice I wrote that formula down again. I wrote that formula down for every single problem. Okay. And the only two numbers you need to figure out are A1, which is your first term, and D, which is your common difference. What is my very first term of that sequence? 4. And then what's my common difference? 1, positive 1, because they're going up by ones each time. All right, so to find my nth term, what we would do is 4 plus n minus 1 times 1, but I'm going to put the 1 in front. 1 times n minus 1. Okay. Now you distribute the 1.
Do we leave the 4 alone?
As of right at first, you leave it alone. But then after you distribute the 1, you're going to combine it with that constant, with the other constant. So it would be 4 plus 1 times n is n, and 1 times negative 1 is negative 1.
So if you have a 1 in front of the n, just the n.
Yes.
Alright.
Yeah, and 1 times anything is just going to be itself. All right, and now you combine your like terms. So you would combine the 4 and the negative 1. 3. So you'd have a sub n equals n plus 3. Or 3 plus n, whichever way you like to write it. So that's my equation. Now they want me to find a of 25. So how am I going to do that?
You do a n equals, well then you have n plus 3, so then you have the 7 n for, what, 25?
Yes. Yeah, because that's what we define the 25th term. Yep. So to find the 25th term, you would do 25 plus 3. So that's 25 plus 3. So our 25th term would be 28. All right, let's try the last one. Write an equation for the nth term of the arithmetic sequence 1, 0, negative 1, negative 2, and then find a subscript 20, which just means the 20th term. All right, so you've got to figure out what to plug in for A1 and what to plug in for D. Brandon, what am I going to plug in for A1?
The 1.
Yeah, 1, because it's, my first term is 1. Now you've got to figure out the common difference. Morgan, what would you say the common difference is?
Negative 1.
Yeah, negative 1, because they're going down by 1 each time. All right, so now to write our formula to find the nth term, we would do 1 plus negative 1 times n minus 1. You said you think you did it wrong or right?
Right.
All right, so first you multiply both by negative 1. So a, the nth term would be 1 plus negative n plus 1. Negative 1 times n is negative n. Negative 1 times negative 1 is positive 1. Now you combine your like terms. What's 1 plus 1? So it would be 2 minus n or negative n plus 2. Either one is fine. And it wants us to find our 20th term.
Will we make that negative since the n is negative? Or no?
Make what negative?
The 20?
Yeah, it'll be 2 minus n and n's 20, so it'll be 2 minus 20. Go ahead.
Negative 18.
Perfect. So our 20th term would be negative 18. Now, if you're taking a test, or especially like the EOC or the ACT, if you can't remember that formula, then please by all means go through and subtract 1 each time until you get to the 20th term. But this is just a shortcut. This formula is a shortcut for you to find that term without having to go through and do all that work.
Is this page 21?
Oh, yeah. Should be.
Alright. Everybody confirm that this is page 21. Okay, so page 21, 4.6, arithmetic sequences. Fill out your table of contents. Tomorrow, you're going to be doing pages 124 and 125 in your student journal. You'll be working with your partners on those 2 pages. If you look at those, there's quite a bit of problems, but like I said, we'll be working on that the whole hour tomorrow. And What's tomorrow, Wednesday? Thursday, you will have your worksheet. Friday will probably be big ideas. Monday we'll probably review. No, we won't even be in here that long on Friday.
Like 20 minutes a day, so
Yeah.
This evening.
So you'll probably have an assignment on big ideas, but it'll be really small. It'll be a small assignment on big ideas, and then Monday you'll have a quiz. Tuesday we'll review. Wednesday will be your test. Okay. All right. What questions do you have for me? So your chapter 4 test is a week from tomorrow. You still have like 5 minutes left of class, but you can go ahead, get your stuff ready, put up your calculators, get your phones, but just have a seat. You can talk, play on your Chromebook. If you need to work on something, but you get 5 minutes of free time today.